Hey there, guys, and welcome back. Sorry, just turning off my speakers there. Forgot they were on. So, let us talk about the elephant in the room here. Oh, shoot. There it is. Okay. Somehow it looks like I went to desktop for a second there, but we are back. Whoopsies. A little bit of a rough start to the stream. But, let us talk about what we built last time. This thing that we're staring at right here, as you can see, it is in fact an expanding filament spool holder. That is definitely what it is. It is not the kind of filament expanding spool holder that we needed, though. That is the issue. Basically, at some point along the line, I was sitting here talking about, spool holder, got this kind of thing for 3D printers, and my brain got fixated on that, and I put a bearing up here. The bearing is the exact wrong thing we need up here. This really needs to just be a flat plate, potentially a curved flat plate, which is not flat, but regardless. Yeah, that was a bit of a mistake. Was at the end of this, towards the end of the stream at any rate. And I did say, I'm pretty sure something is going horribly wrong here, and that's why I was going to end the stream and get dinner. Yeah, came back from dinner and went, oh no. So, whoops. Yeah, we overcomplicated this more than we need to. Now, just in case you're not following why this is a bad thing right here, why putting a bearing up here is bad. The entire point of this thing was for the coiling mechanism to spin the spool. We were trying to spin the spool, and if it has a bearing on it, the cage that we're building right here is going to spin itself inside of the ID on the inner diameter of the spool, and that is not going to turn the spool. So, whoops. Again, whoops. Fortunately, this is a pretty easy fix. So, we can fix it, and just more embarrassing than anything else, frankly. Let's see. Only thing I need to double check is whether or not, before I delete this, we have anything required. We do not, so I can delete these two guys. Whoops. This guy and this guy. And delete both group and contents. That is reliant on something. I don't know what. Position. Oh, yeah, position is not in the list because it's all the way up top. I would explain that one. Let's come back down. So we got rid of our bearing. This is the shaft, yep. So we can delete that and that. Don't need either of those. That is the hinge, we can keep that. And this guy and these guys, likewise, do not need that hole. So at this point, we should be able to just come back here and work on this. At this point, everything is going to end up shifting up. These hinges are going to get longer because this flat point right here at the top of this hinge is basically exactly what can go up against the inside of the spool to hold it in place. So we will go ahead and just get rid of all this extra nonsense that I put in here. And this is my bearing right here that, again, we had the unfortunate mistake of saying, oh, 608, that must be 6OD, because I was not being intelligent. And like I said, at this point, that can just go centered on that. And as for the width, the width, it can move in and out. It's not necessarily a problem. Whoops. I guess it's a question of how much surface contact I want. And also, I centered this on this. Well, so long as we extrude this in two pieces, I guess it doesn't necessarily matter. Yeah, it doesn't necessarily matter that I centered it. Okay. So, let us check actually how much space we have to begin with. And, oh, I already put the purple spool away with the smaller ID. 1 second. And let's see what we got on the inside here. Let's see, best way to measure this, I guess more or less like this. Get me close enough. Alright, looks like we just need to be under, batteries are dying on the calipers, but under 40 millimeters should be fine. So if we make this 20, that should be more than enough. This guy right here is, let's see, 2 millimeter, well actually it's 1 millimeter too, because we don't connect until this point right here. So 1, 2, 3, 6. So 6 and 20 and 6 is 32, which is less than 40. So we should be good with this. And that gives us plenty of surface area here. And then it's a question of how wide we want to make it. The other question is, do I want to put a little bit of a roof on it? So you can see how the hinge itself is going to be impacting, in theory, the spool. I think I do want to raise that up actually a little bit. So rather than this being centered on there, we will drop this down. I'll draw an extra little bit of meat here. And this also gives us an opportunity to curve this. So on the inside of the spool, obviously the ID, we do not have a flat area. Well, let me extrude this first just so that I can demonstrate. We'll call this, yeah, 3 is fine. I'm okay with 3. Get this quinky-dinked, and yeah, we're fully constrained. Good deal. Wheel holder and hinge, that should now be contact plate, I guess. Should be a better word for it, but not really that big of a deal. Okay. So, so in theory, the spool is round like this, right? So if we put this right up, we snug this right up against it, then only this edge and that edge are making contact, and we got a space in the middle here. Now, one of these things, we have 2 different diameters here. We have a 2-inch and a 3-inch, roughly speaking. So we can't get the exact radius on this thing, but adding any kind of radius should help add some more surface area. So we will go ahead and, yeah, I think I'll do this separately. I do want to radius this too, just for looks, the corners. But let's see, how far do we go? I mean, that's fully around. I don't know if we need fully round. Maybe we just go to 3. And actually, so this is 9 overall, right? Yeah, so that makes sense. 3, 3, and then 3 in the middle here, probably. Yeah, 3 in the middle. That is, in fact, how radii work. And again, I will go ahead and round these guys down just for looks. Alright, 2 point. I mean, do we really need it that much? I guess I can just break the corners a little bit. Just because I am losing a little bit of contact area by doing this. Should be fine. And one of these things, I was looking at this yesterday and I kind of felt something was off here, but probably just my imagination. Okay, so that is that. And the last thing that I want to do, well, it's I guess I should just put it on the piece that the coupler on the shaft. I should just probably just build into that. So yeah, we're gonna go ahead at this point then, and yeah, rotate these guys around like we did last time. Pattern them around. The spoke. No, components, spoke. That's why I couldn't click it in the browser. And around there. So again, 3, 4, 7, 10, 24. I don't know that there's particularly a number that works that much better. Like, I feel like there's a little bit of fall off here, but that is kind of just an intuition thing. So I'm going to put it at 4. Nah, I take it back. I'm going to put it at 3. I like 3 better. Okie dookies. Do I like 3 better or do I like 4 better? The big decoiler we have at work or actually both decoilers we have at work are 4. spokes. So I think, yeah, all right, I'll go back to 4. They both have 4. I guess we may as well do 4. Okie dokies. So now I'm going to put a connection point for all 3 of these guys to connect to. And then we are going to, again, this in theory could be a screw, in which case we could screw these guys, these ends together to get them together. Or alternatively, we could have a separate screw, so we just put a little nub up here with a screw going through from end to end, tying down just that one screw to drag it together, with this being a blank rod. And the other option, I mean, there's a million options, but the other option that I would consider is just using my hand to smush it together and then putting a collar and holding it in place with the collar. That is the other option, which is simpler, but doesn't give you as fine control over tightening it down. So, and I should mention, with this screw, you're better off putting nuts, like just having these sleeves like I'm going to build right now, just having the sleeve like I'm going to build right now, and then having a nut which pushes into the sleeves. So that is the story there. I wonder how difficult it would be to thread an entire 8mm rod. I've never actually tried it, like with a die. Huh. That is an interesting question. What is the pitch on the 8mm die? It's burnt, and so it's one of these things. I got them, my boxes stacked up in size order, which means that the die and tap set that I have is at the very bottom because it's the biggest. So I'm kind of hesitant to start digging through and pulling it out. I think it's probably 1 or 1.25. Actually, you know what? We can always consult the internet. Let's see. M8 thread. M8 threads. Do I have a chart somewhere? Alright, here's a chart. Let's see. M8 threads. Okay, M8's... Okay, according to this chart, they go all the way from 0.5 to 1.25. I'm guessing that I don't have anything below 1 in my die and tap set. I'm guessing it's, if I do have multiple, it's 1 and 1.25, or maybe just 1. But that is an interesting idea. Back to, I get these 5/16 rods for free from work because they're scrap. So I could literally just try it. I could literally try tapping an entire rod and seeing how it turns out for this project. That, however, would be, well, let's see what the difference is between an 8mm rod, buying it online, and 8mm rod versus a 8mm threaded rod. Let's see. Alright, so just off the shopping tab, rather than going to Amazonia. Alright, one of those things, it's going to have a whole bunch of different sizes, which is going to make the price comparison a little difficult, like a length rather. And these are, it looks like 1.25 is what I'm seeing here on pitches. Although a lot of these do have the, I think a lot of these have the double pitches, whatever you call those. I forget what the actual name is for it. The funny thing is that it's not actually looking that much more expensive to get, if at all, that much more expensive to get a threaded rod versus a solid rod. Huh, interesting. Yeah, I mean, alright, I am going to hop over to Amazon then, because it's one of those things from different sites, I'm getting all different numbers, so rather than try to do the math in my head, I should be able to get pretty consistent numbers from Amazon. Let's see. 2 for home, thread rod, $10, $2.50, $7. That is the threaded rod. $6 for $2.51, $7 for $2.51. Okay, now just regular old 8mm rod. 2 for 11, 2 for 9, 4 for, well, those are hundreds. Those are all hundreds. This is 300. Can I get a 250 for a better comparison? Yeah, I mean, the fact of the matter is that the threaded rod actually looks like, in some cases, it's a little bit cheaper, and I don't know if that's a matter of straightness tolerances that people aren't as worried about with threaded rods. I don't know. Or just the finish, the fact that solid rods are supposed to have a nicer finish on them, whereas it's not as important with the threaded rods. So, in that case, I do think we will be going with the threaded rod on this one then. And I'll try to make one again at work. But otherwise, it looks like the price is near, if not slightly cheaper for threaded rod, and threaded rod is, frankly, easier to work with here. So we are going to do this guy. Come in here really quick and make this guy threaded. Threads. There they are. And yep, 820 1.25, 8 1.25. And then we can come back up to central clamp and build our actual clamping mechanism. And I probably can just mirror it from one side to the other, which is nice. So we'll go ahead and create new component. Let's see. Do I want to call it sleeve? I kind of want to call it sleeve just for simplicity's sake. One other thing I meant to mention. The fact of the matter is that this end over here, this back end, could be fixed. You don't necessarily need to tighten both ends up at the same time. You just reposition where this is at. Because we're only going to be using one end. Alright, so here's the thing, right? We're only going to be using one end. You probably want the other end available to just at least put in a bearing. That was my plan, to put a 608 on both ends to help it spin. But regardless, the fact of the matter is that the 608 on the other end, on the back end, can always be in the same exact place. You could just set this up once on the back end and then always move the front end. That is definitely a possibility. And the only thing that changes is where that sits inside of the spool, which may or may not be a big deal, so long as you leave enough space on the back end. So long as you leave enough space on the back end, then whether or not you have more rod sticking out the front end of the spool or less rod, in theory, doesn't necessarily make a difference. Again, in theory. The last thing I will say is this rod right here, getting the motion onto it from the motor, because it is, well, one way or another, if it was not threaded, I'd be more comfortable putting a D shaft or something like that on it, just cutting one on, or otherwise, alternatively, just pinning it in order to transfer the space. With it being threaded, you can still do that. You can actually still do both of those things. It just feels a little weird to me, and that may just be me being weird, but just feels less natural. Your other alternative is to put lock nut, just backup nut, jan nut, whatever you want to call it. Just toss 2 of those on there, and you can go ahead and torque off that, because they will keep each other from moving. So that is the deal there. That is some considerations. I don't really want to call it the expansion sleeve, so positioning sleeve, I guess. Okie dokies. And I think I'm going to design it in the middle and then align it with one of these holes. I think that's how I'm going to go about this one. So there's our rod. come out, give ourselves like 2 millimeters, I guess, because we're so close already. That's probably all I budgeted myself yesterday. And again, as I've mentioned before, the interfacing for the hinges is easier done from the other direction, so I'm just going to go ahead and expand this out now and then, and then come back in with another sketch. How thick do we make these guys? Because I only really need to be as thick as these guys are. So let me come back over here. Let's see. This is 3 plus 2 plus 2 is 7. So these are 7 millimeters wide. And technically we don't need the full 7, but the 7 does in fact give us a 2 millimeter wall on the other side of the mounting point, which makes sense. So this is actually, we were starting to do this last night, and I said, oh yeah, that's right, because we need to join it with the whatchamacallit and the whatchamacallit and the whatchamacallit and that, yeah. Those were my exact words, more or less. So again, as I mentioned last night, I believe there are a couple different ways we can do this. So we're gonna have a 2 millimeter wall. We talked about we didn't talk about how thick we're going here actually. So this is 3 millimeters. So we could go 3 millimeters thick over here. This is a possibility. In which case, what we would want to do is go minus 3 millimeters. I'm gonna say minus 3 millimeters just because I like working from the front direction better, and that's how the placement of the offset plane happened to turn out. So this would be, or actually I should say, so it's minus 1.5 and then minus 3, because my 1.5 gets me to this face and then my 3 gets me to the face of the other one. So we can do this, hit that, and then intersect, or that is not intersect, that is intersect. There we go. That. So that line right there, you'll see how that's lower than the top, but that is my bottom line for the rod where we reach through the where the plastic is basically. So if I extrude this out, if I make the shape and extrude it straight out, worst case scenario, I just breach into the rod area and then I just need to clear that back out. I just need to come in and hollow that back out again, as opposed to if I used to project, I'd have a line up here and then we'd have a gap between my hinge connection point and the collar right here, sleeve, whatever I feel like calling it. So that is that. I should say the other alternative, okay, to doing it this way, because I was saying this was an alternative. The other alternative is just to design it right here, okay? So go like this, okay, and go 3 millimeters, project this out. Yeah, I should probably just grab the hole. There we go. That way I know where the hole is. So this is going to be collinear with that hole. And then I want a 2 millimeter head room, 2 millimeter, 2 millimeters of plastic around that. And then this guy can just be anchored right there. And technically speaking, I did this guy down here. Totally not necessary in this situation. This guy can go right here. And we can also do the same thing on the other side, so we can extrude both at the same time or with the same sketch. Otherwise, we can just mirror it across. Save ourselves a little bit of effort. So we finish sketch. Include that guy because we're going to want the whole length here just because. And then take this offset plane right here. And it's one of those things. This means that I don't have to come back in and clean up the other stuff. It's pretty simple. So The one thing this does not do is put the corners on. So I would have been able to sketch the corners on from this view right here with this sketch that I was using. And now instead, I either got to draw them in here and then extrude them out, or use the fillet tool. Again, the fillet tool I don't have any problems with, so fillet tool is simple enough. Me doing this right here is a little silly, okay? Basically, instead of doing that, I could do this. Give myself my 2mm here, 3mm hole, and then tangent. We know this works. The reason not to do this is in case we change this hole, because these numbers do not match, and we have not been using parameters in this design. We've been doing everything basically freehand because I wanted to get it done quick, and I was expecting it to be a quick project, and therefore doing it this way, setting this as equal, that is directly across, so we know that that is in line when we shift this over. And all I got to do now is just center it, and we should be groovy. There's that, and there we go. So now just distance all, flipperoonie, objects to cut, just the positioner is good. Toss this on here. 2, I guess 2. It's one of those things, it could be 3. I mean, that is 3.5. Oh yeah, it's 7, so 3.5 makes sense. 3.5 does in fact make sense because it's 7. Okay, yeah. And then we'll just mirror this all across. Again, I'm gonna go ahead and come back here and delete that other sketch just because I've already taken all this time, and it does give me a little bit more flexibility. Back to, I have this trial thing running accidentally, and by accidentally I mean I did not click I accept or anything like that. Fusion decided to unlock it for me. It kind of stinks that I'm not using any of it because I'm not in position to... Oh shoot. Alright, remember when I extruded everything all at once, and I wish that would stay hidden because I have the full desktop capture Fusion, unfortunately. So let's do this. That's all gonna break. We're gonna come back here, sketch, bring that out separately because two-sided, because we need to mirror this. So technically speaking, I probably could have gotten away with mirroring the object with all this all at once. That probably would have worked. I just did not want to, it's a bit sloppy basically, is all it really comes down to. Collar and hinge connection. Okie dokies. So that is off there. That. Fix geometries. Face. Reconnect. Okay. Delete that. It's funny how Fusion decides what is actually supposed to be what face, right? I will never, I don't think, at any rate, I will ever figure out how it goes about deciding it, because it seems like every time it needs to update what the geometry is when you change it, it always spins it 90 degrees or 180 degrees. It does 180 degrees sometimes. 3.5. And I just don't really get it. And before we were talking about what kind of hexes to use here, we do have the space, I believe, on the inside here. I believe we have the space to include capture nuts instead of lock nuts. I guess we'll go ahead and pattern around after we mirror here and see whether or not I am correct about that. Can we get back to features, please? Thank you. That. I want the shaft, please. Do I not get the shaft? Okay. What about the ID here? Huh. Fusion. Fusion. Baby. You're not even letting me... Oh. Derp. Alright. Goodness. Okay. Everybody laugh. That is what we like to call somebody talking about something and then not going back to what he was doing. So, in other words, I was thinking circular pattern already, and we did not even mirror yet. So, now we can circular pattern. Just leave it on adjust and see what adjust does. Adjust appears to work. Now, the question is if I put this out 2 millimeters for the capture nut, does that interfere with the bolt head is the question. I guess we're about to find out. Actually, we can find out like this. So let me go ahead and... Yeah, alright. I'll project it first. Bolt head is about 5.5. Yeah, we got plenty of space. Because I'm only coming out 2 millimeters here. Bam. Alright, cool. Yep. So we can come back in here and back up one. Toss this plane on here, and I did not name the other ones, which is a little bit of a mistake. Front of hinge, front of bolt side hinge connection. Huh. What's are you? Oh, you are from the previous sketch. Deleted. Front of bolt side hinge connection. Try that again. And front of nut side hinge connection. Hop on here. Project. Put a nut in. Capture the nut. This does print a... I guess it should print okay. It's not any worse than normal. Oh, actually, I guess that answers my question. We're not doing this. I don't have enough space to put the capture nut on. I take it back. I take everything back. I don't want to take back renaming stuff and deleting the other one, though, so we'll just delete that. So these will be lock nuts. And now I can go ahead and modify a line. And, whoops. This guy to this guy. Yeah, we can capture vision. I have no need to do otherwise. And again, this can just have a nut pushing it in. Alright, I say that technically, well, alright. So what is going to keep it from just continuing forward? So just having a nut on this side, this in theory could continue going, let me attempt to, this way, right? Towards the center, because the nut's only stopping it from going this direction. What's in theory going to stop that is the pressure against the inside of the spool. So when it's not in the spool, this whole entire thing can in theory collapse in on itself, but once it's inside the spool, then it's limited by the height, because as again this goes in up until the point that it's at the center point, and we set this up so that it's at 80 degrees at max height, or at the 3 inches, which is our max height. So it would have to go past 3 inches in order to get past the midway point, past the point that these are vertical, at which point then it would start getting lower because these are coming inwards past the midpoint. So that is why we are okay. And we can go ahead and create a mirror. Actually, let me come back with the central clamp first. Create mirror components, positioning. We're going to change the name of that. This is now positioning collar. And I probably should have changed the name before I mirrored it, but that's okay. Okay. Okay, yeah, that is everything we need. So, the next thing we should put on here is, again, the 608s. So, let's go grab some 608s. And I believe those are in downloaded assets for me. This is just tools for removing stuff. Yeah. So, that is under my folder for downloaded assets. And we're going to come back up to coiling yeah, this guy. And there's my 608. Insert. Proceed. Okie dokies. Bring them out here and then we'll move them back in just a minute. Close that. Modify, align. That to that edge. Okie dokies. And actually, you know what? Let's just bring another one in instead of mirroring it. Insert. Proceed. Gives me an error even though. Okay, modify align. Easy peasy lemon squeezy. There we go. And now we just need to toss these guys onto something we can connect to. Again, we're going to make for whatever reason I decide we're going to make a couple different frames to hold this in. It's a bit unnecessary. I mean, you know. Let us see. You know what? What? I think. Yeah, I think I'm not going to actually put the plastic around these just yet. I think I'm going to design that per frame. Yeah. So I'm going to leave the bearings here, but I'm going to just put the plastic per frame. The other thing to note about the frames is that I should figure out. Actually, it's pretty simple. I just take the length of this and then add the thickness, or not even the thickness, because the end of this should be up against that wall. So I should be able to take my 20 millimeters that I have in here. Let's capture position really quick. Take my 20 millimeters that I have in here, add the length of this guy, the overall length of this guy, and then that should be the full length, plus times 2 obviously, for 2 sides of this fully extended. And I'll adjust the length of this rod to match that. That way I can determine where or how big the frame needs to be, is the idea here. Yep. The other thing is, so long as these rods, this rod, I'm saying these rods because I'm jumping ahead of myself, but I think I said that we technically can, because we only need to come out to halfway point, we technically can do a 3D printed mount for this as well. And then I said also the conduit and the 2020 extrusion styles. So with the printed mount, so long as this length doesn't extend past, let's say, 255 or 250 millimeters divided by 3, then in theory, well, 3 is maybe not enough, but I'm just thinking we can use the 2 cutoffs to build the frame. So you put a little nut on it, and then on each end put the A-frame on, and then put a nut on the other side, if you're following me. We'll go ahead and model that up just so you can see. But it really depends on what this length ends up being. So let me go ahead and, as I was talking about, getting this length and updating this. I guess I'll grab it here and here, and hopefully it gives me, oh, unselected this somehow. There we go. So what's my maximum distance? Maximum distance is about 29. So 29 and 29 is about 60 plus 20 is about 80. So 80 millimeters divided by, or let's say 250 divided by 80 millimeters. Calculator. 250 divided by 80 is about 3 1/8 rods. 1/8 of 80 would be 10 millimeters. So we're going to have 10 millimeters cut off, which is not a bad drop to get 3 rods out of a 250 millimeter stock length. They do come in 250, 300, 100, 400. I believe are the popular sizes, maybe 150 as well. The 300 is only 50 more, so that's 60. So that's not enough for a 4th rod, so it'd have to be 400. 400 is 150 divided by, which is 160. So it's one of those things, so long as you discount the 1/8 of an inch that you lose off of cutting it, generally that's a good round number to use, is you lose an 1/8 inch of material when you're cutting an object with a saw. About an 1/8 inch is lost, let's say. So if you lose an 1/8 inch, you're technically below, but 400 does divide by 80 equally. So you know how this was not exactly 30, this was 29 plus a little bit. We could get lucky and end up with enough material for all of that then in that case. Although yeah, 80 is the full length on the inside here. So I did not take into account these guys right here, the thickness of these guys, plus the extra bit sticking out the end that you're using to drive the whole entire mechanism. So that is probably not going to work. We're going to go ahead and design for it anyway, just see what happens. But maybe not holding our breath. Okay, all the A-frames are going to look basically the same, so we should be able to knock them out really, really quick. Although I'm probably going to want to start a new file, a new document. This says new design, but I'm pretty sure they're all considered documents. For an 45 angled piece for 2020 extrusion, because I do not actually have any of those, so I'd have to print that, which is not a problem, but I do have to design that in order for it to work. Well, in order to print it, I should say. I have to design it to work at any rate. All this being said, I think I am going to BRB really quick. So I will leave you guys with the music for just a minute and BRB. Alright, and we are back. So, let us go ahead and make a couple of those frames. And then we got to talk about the, the drive mechanism. Actually, I take that back. First, let me go ahead and central. Where is? I'm blind. Oh, is this just body? Did I goof up a little bit here? No, that's not just body. Oh, center rod. There we go. I just can't see where I'm at. Oh, BRB still on the screen. My bad. Alright. This, I believe, is just symmetric extruded. I'm going to go ahead and hop in here. And I want to just extrude it from one side. So this is the front. We're going to go right hand side here. So, Actually, I take it. I probably should just do that. That would make more sense. Oh no, I know I was going to do the other side. I take it back. I take it back. I was going to do the other side because. Back up just a half second. Huh. My extrusion disappears when I go backwards. Okay. Back to my overall is going to be 80. So, I wanted to do it this way. Join. Okay. And then do that. There we go. That way, only one of the bearings may move, and even then... Oh, that's right. This needs to be longer than 80. So the bearing thickness, let's check. We should add that on. Where's my bearings at? Oh, we have to move forward in time. That makes sense. Because I hit join? Really? And how did you get all the way out there? That actually makes less sense. Huh. Huh. Alright, so this is, so it's 80 plus 7 per is 14 plus some length to drive on, so let's call that 15. So 14 and 15 is 29 rather. So we round it up to 30 and we get up to 110. So let us go ahead and modify this guy. I think it's this guy. Nope, it's that guy. That guy right there. So minus 110. Join. Okay. And again, I'm not actually sure why this projection is lost because it was just a join. I guess I get it. Because I did the face and not the body. Had I done the outside body, it would probably still be fine. But because I did the face, we replaced the face that was previous there with a new face because we overrode it. We joined it. So I guess that makes sense. The positioning here, however, on the back end should not have changed. That should be exactly in the exact same place that it was before. So that doesn't make sense. Oh, unless I got to go forward one. There we go. Now. This guy. Let me bring you forward and then I'm going to edit you because you need to go from the backside here and then move 80. So there's the backside. And then I need you to linearly move. Let's go to translate. 80. Okay, cool. And that is the maximum. So this will be butted right up against that. I should leave space for the nut as well. The nut, it's an 8mm. I actually don't know that I have 8mm nuts, fascinatingly enough. Interestingly, I also don't think we have 5/16 nuts at work because those rods are solid and we don't actually put nuts on them. We don't actually tab them and put nuts on them. So, I guess it is time to consult the internet because, again, actually I have a lock nut. Would it make sense to use lock nuts on this? I don't think so. The fact of the matter is that A backlash nut would also actually make more sense. I guess backlash nut is not necessary. I'm just thinking it helps hold position. It will help push against the threads and hold position. Is kind of what I'm thinking. Let me check if I have an 8mm lock nut to give away. Let's see. I do. I have up to 12, as it turns out. So these lock nuts are, let's see, about 7 3/4 mm. So we need to add that in on. Well, here's the thing. I should probably. I should probably fix this guy in place. I probably should put like a nut on the inside and the outside of this guy to keep him from moving. Or a collar. One of those things. I technically could use a collar on either and or both sides. But I need to include that length in the threaded rod. At least on the outside. So if we leave ourselves 8mm of extra space, so that brings us to 16mm. So let's add another 16mm on here to make sure we have the space. Finish position. So that's 26 now. It could be 25, honestly. I'm probably not going to miss the 1mm, and it makes my life happier. We're good on the sketch. We don't have to fix the sketch. This guy does, however, have to move another 15mm or 16mm for those two nuts we put in there. And finish. And then let me just check this, because this should be, I think I said 15. Yeah, 15. There we go. Cool. And again, technically speaking, we're moving less than the 80 in here, but that is besides the point. So the other thing we could do is rather than having a nut on the backside here and then a collar on the inside or something to that effect, a collar on each side one way or another. The other thing we could do is actually extrude out some plastic and put either a set screw or a pinhole through here and pin this one directly to the shaft to keep it from moving. That would be an easier way of going about it. Definitely worth consideration. I'm gonna go with the simpler method of just using collars and or nuts to hold the back end in place to make sure that it does not slide forward and then dip, you know. So that is gonna be that. Yep. Okay. Now we go back to building the frames. So create new component, plastic frame. Let's see. Yeah, I guess just from center. Just from center makes sense. And then we'll extrude it based on the bearings. So let's get the bearing OD in here. Grab some more coffee. Turn this off because we don't need it now. We said from the center, and this is the center, to the floor was, I believe, 8 inches. So 8 inches should be more than enough. It should actually be more than we need, looking at it with my hand right now, not with a tape measure. So that would be 4 to the center, 4 inches. And now we can do some very simple design stuffs. that you are very much probably familiar with. So here's 3mm right here around here. We're gonna go ahead and toss those rods I was talking about in over here. Toss a general frame. Again, we're just gonna stick with A-frame style because that is simplest around here. And we're almost done already. Toss some offsets here. Make that centered here. Make that perpendicular. Whoops. Select the correct stuff and then make it perpendicular. And this will be like 3mm, I guess. And 3mm bolts, rods, whatever. Oh, that's right. We were talking about using the 8mm rods. So let's change that to 8. Control Z equals. There we go. Tangent these boys up. Tangent those boys up. And then it's just a matter of how wide we want the base. So if I have a circle here, and this is my, in theory, spool that is slightly larger than the actual spool. Please, thank you. Okay, cool. So, one of those things. We could bring this like, honestly, it is kind of an eye thing, like what looks good. Only because this, oh no, I mean, well, to an extent, right? Because this right here, that one instead, rather. This is the smallest it can be because the rods just barely pass by the spool. So that's the smallest it can be. Otherwise, it's more or less what we feel is comfortable and what we don't think is going to fall over. The other thing I should probably actually do... Oh no, I already have 3mm here. I was going to say I should probably have this away from the floor, but that's 3 away from the floor, so that is fine. Boo, 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 boo. Anything else? Anything else? I am not thinking so. Yeah, alright, I'm just going to figure out what this is here because this looks decent enough to me. And round it off. And then we can go ahead and extrude this. Turn that on. From object. There. Distance to object. There. I mean, we don't really need it that thick, I guess. Nah, I think I'm gonna leave it. Yeah, so again, very simple A-frame construction here. Then we'll just actually delete that. New component is what I should have done. Object, 7mm of plastic. Oh, we did not actually select any profiles. Good us. That, and that. Cool. New component, move component, create a copy component. Create copy. Just move it out here and then realign it. Align. That and that. Or maybe not. Modify, align, that and that. Okie dookies. And then again, Using two threaded rods along the bottom here to hold this together. These bearings will be pressed into this plastic, so that should keep the top from swaying, in theory. Yeah, I mean, there's not really anything else that needs to be done here. We'll just put, again, this will be threaded rod down here. So we'll just put nuts on either side to make sure that it stays. No, I don't think I want to do captured nuts on either side because that makes things a little bit difficult. It complicates things, so I don't think I'm going to do that. Plastic A-frame. Yeah, and one of those things, because I used the copy inside of the movement thing, you can see that any changes that I make to one of these is going to be reflected in the other, which is normally a problem, but is not going to be a problem today because I am not actually doing any other changes to this. This was just a simple mock-up just to demonstrate and to have it available in case you want to print it. Have we started yet? Oh, excuse me. Orange. And then we can do similar stuff for the conduit and the extrusion, unless we want to do something a little different. The fact of the matter is that this triangle shape is more or less the easiest thing to do. Obviously, we do need to, for the extrusion, for example, print out new corner pieces. However, that is not really that big of a deal because this is, especially because rather, this is not weight bearing. So the actual question, though, is how we want to design those corner pieces. So let us go ahead and work on those corner pieces really quick. Miscellaneous. 2020 extrusion. I gotta save it first. And yes, I do want it in miscellaneous. 45 angle bracket. So, please, thank y'all. Okay. Break this. So the two ways to do it. The two ways is to put the angle bracket in line here, or to put the angle bracket on top. Either of those ways work, technically speaking. The angle bracket on the side, you don't really screw in, you just kind of press it together and then hope it stays there. You could technically screw it in. I could definitely do that. The problem in both situations is actually getting them connected. Actually, let me copy, paste as new. There we go. And set this to 45. Okay. Actually. 0 up here. Now 45. And this is technically not going to be correct, but maybe like that. Okay. I'm gonna hit OK in capture position. We'll realign this in just a minute. What I was thinking was that in theory I have an obtuse angle on this side, However, that only actually works if I miter this. If I cut this extrusion at a miter angle, at a 45, at an angle, then I have an obtuse angle on this outside, and that is easy to T-nut in. But I don't really want to. So I don't really want to be cutting angles on these guys. So that being the case, we are kind of at least, so I could still do bracket on this side, extend it out, and then T-nut straight down over here. That's definitely an option. The other option, actually the third, fourth, fifth option, whichever option I'm on, is to put the brackets on the side. That is an option. Actually, I could do a combination. So I could put the bracket on the side. So we're up to like option number 20 now. Plug this piece into the bracket, and then have the bracket extend down on the sides and even up here too if we wanted to, and T-nut in. Just because the problem is that getting to T-nuts on the interior angles here, the acute angles, is rather difficult. So oh. How do we want to go about doing this? Alright, so I'm going to actually go with option 1.5, which is to do the corner bracket on the ground here. And the half version is that I will go ahead and put a hole so that you can tap these guys and screw into these guys. And I will go ahead and put little alignment flanges in there as well. I think this is the happiest medium. I think. Yeah. Actually, I don't need to make a new component because that's all we're doing in this one. So let us go ahead and go here. Project this out. So this is going to be the start of my bracket. And I will go ahead and make a box along that guy. Yeah, I know we were making a Coiler Decoiler thing. I know that's what we were doing at one point. But the terms have changed. Pray I do not alter them further. Minus, how much thickness do I want? 5? Okay. Or I guess I should have done +5 because we're going the other direction. New body. Okay. Let's go ahead and align this really quick to get him into position correctly. Okie dokies. And then capture. Project all this. How do I want to do this? Do I want it to be square or do I want the rounded corners? I guess I want it just to be square. I guess that's what I want. And actually, I didn't need to project any of that stuff. I could just project off of the other sketch because I already had that square designed. Okay. Bottom attachment, flanges. Bottom body. Body. There we go. Turn you off. Extrude that. We will extrude it some amount. Let's see. I know what I'm going to do. I'm actually going to draw the angle in first. That's what I'm going to do. Finish sketch. Project that. And then from there, I want 20 millimeters at a 45-degree angle. 45. 20. There we go. And I can finish sketch. I might come back to that later, question mark. Question mark. Or we can delete that guy. Remove this geometry. Delete geometry. Project in instead this guy right here. Oh no, that's not gonna work. I'm just thinking if I make the angle right now, that saves me a step. Alright, that's what I can do. Okay. Let's go forward, go back forward really quick. Finish sketch. And then do this -5. Do this. What did I just click? I was trying to click this guy. Make sure you slide back now. Turn you off, turn the body on. There. Okay, capture. And now we can go ahead and corner extrusion. Come back in here. This now did I project it? I did already project it. Cool. That now can come all the way and connect there. Cool. And 45 degrees. 45. And then I can go ahead and draw this out again so that I can extrude this all at once instead of in multiple pieces. That was the whole entire point of doing it this way. Bodies. Distance, two-sided. One side that way. That is a -10, so that is the incorrect way. To object. There. Distance to object. There. And join. And then we can go ahead and this was the Are you just floating? I think you're just floating. I don't think we're using you anymore. Alright, cool. Now, anyway, back up here. 45 face. Draw it. Actually, finish back up and then align. Modify align. That is not modify. This is modify. Let's get this centered on. Centered on this face. Centered. We can flip that around though. Okay. Take a quick look just to make sure that we're not really. Yeah, you know what? Maybe. It's a little tight. It's a little tight. I'm a little concerned that we're going to have some interference problems, but I actually don't really want to change it. So the only other thing I'm going to change here actually is give myself an extra 3mm wall on this side really quick. That 20 is correct. I'm going to change this connection point here. And, oh, this distance is, whoops. I don't know what happened here. Revert, please. Thank you. This distance was actually supposed to be on this line. Thank you. Whoops, 20. There we go. And now, right angle and connect, and 3mm. There we go. And now we go forwards in time, and it looks like we lost that alignment. So let us modify align again. Center to center, flip, capture, okay. And now finally I'm back over here, project that face, get the flanges in play. And furthermore, I can go ahead and make this a full circle, and probably also include the so 6mm, the head on a 6mm, and that shouldn't be an offset, that should just be a diameter. Let's see, where's my box at? There it is. $6mm. Here we go. All right, 10.3-ish, 10.3-ish. We'll call it 10.4 just because I should have the space. I don't see any reason why I shouldn't be able to. I will, however, turn it to a construction line really quick so I can extrude these guys. Attempt to extrude these guys. These guys do not appear to want to be extruded. So let's turn some stuff off. Oh, I did not project the rest of the Control Z. I did not project the actual face. That would explain that one. There we go. How did I... Okay. This is actually not what I intended, so I'm going to come back and fix this. Let's back up. I forgot. Normally, look at, please. Look at me, please. Normally, I'll go ahead and toss this rectangle in here and cut off these little flanges. So this little extra part in the top, and just use the triangles. And furthermore, you see these little bumps in here? I also cut those guys off normally. So let's toss another rectangle in here. And honestly, I should just come back later and do these bolt heads, because now I've got way too much on the way too much stuff in the way to extrude around, too many profiles. There we go. Finish. And this is actually all I wanted to. So 5, join, and let's come back here to this guy and do the same thing that I forgot. 1 square, 2 square, 3 square, blue square. Alright, there we go. And then we just need to fix the extrusion. Unclick these guys. Okay. And I'm not actually sure. Oh, okay, that's why. The two objects are no longer accurate. I should just do that guy and... Or actually it should be... Because I think that's a -10 on that side. If I recall correctly. It should be this guy and this guy. Okay. There we are. Now, do I just do the bolt heads, or do I hollow this out altogether, is the next question. So I could just shell this, right? Try that again. That guy and that guy, 3mm. You know, just do this and then put the holes in here. Let's see what that looks like. Grab this 45 face, project out this guy. Yeah, I guess I'll just grab this edge. I don't want to project out the whole entire thing. So I'll just grab that edge and use that to set this. And then this was 10.4, I believe is the number I came up with. Yeah, that does fit in there. So the only other question is, do we want to change this shell to a bit thicker, like 5mm? And does it still fit at that point? It looks to be very, very tight. Let us extrude out and find out for sure. Do distance all, and then do that distance. Actually, we don't even need the countersink anymore if we do it this way. Although I do want to see, I take it back, I do want to see what it looks like. So let me just distance all and flip it. And hit OK. Okay, so it is, we're off by a little bit, it looks like. So all we have to do then in that case, I'm going to delete this. And if we're not countersync anymore, because I kind of do like the way this is working out here, let's change this to 4.75, should be enough. Actually, Control Z, change it first, 4.75. And yep, appears to be working. So now we can delete this. And what I was going to say is we can delete this and throw that back on this one, because that is not interfering with the extrusions that we're doing here. Tangent. Finish. I guess I should face this way. That makes sense to fix this. There we go. Okay. And let's come back to this guy. Do the same thing. And we can go ahead and use that guy to extrude the hole. Distance all. Okay. And there is our corner bracket. Simple enough. Top attachment, flanges, and hole. And hole. There we go. And since this is the final design of this, I will go ahead and toss my offsets in, which is going to take a while. This actually, I'll tell you what, I know I hate this feature, but this is a good... Okay, never mind. I still hate it. It got the inside as well. I take it back. I was going to say, painting on these offsets makes sense to me. It does not make sense. New offset. Do not need the face. Just need all the parts going on the inside of the extrusion. And also do not need the holes, just because I can always take a drill bit to those. It is more precise to take a drill bit than to try to get the offsets. So, we'll not do the holes. Let's see, I've got 1, 2, 3, 4, 5, 6. 6 times 4 is 24, so I should have 24 profiles by the time I'm done here. We're up to 21, so we're missing 3 of them. It looks like this corner right here. Let's see, where else? That corner? This corner over here. And that is 24, but do we see any others that we're missing? Just in case we did our math wrong, because math on stream. I don't think so. Okay. Minus 0.05. And then I'll do another one down here. I'm doing them separately just because there's so many faces to offset. do 21, 22, 23. Top corner, 24. Minus 0.5. There we go. And I will just color this a color. Plastic. Let's red. Matte red. There we go. Cool, groovy. Save. Okay. Anything else I need? Nope. Okay. Miscellaneous. 2020 corner bracket. 2020 corner bracket. There it is. 45. 2020 45. Did I name it something else? I didn't name it 45 2020. Oh man. I already forgot what I named it. Okay. Good bunch of men. Okay. I don't have an edited, recently edited features anymore, like in editable features now. Okay, recent data 2020. Why did I not see that in miscellaneous? I know I saved it in miscellaneous because I checked first. How did I totally miss this? I am blind. 2020. Oh. Huh. How did it end up after 6,700? 2020. 2020. 6700. Okay. Okay, I guess that's the thing. Don't insert yet. Let's go ahead and get ourselves another frame. And I'm not going to, I think I am going to skip the conduit one, at least for right now. Just because, one of those things, it is just a repetitive pattern here. That's the word I'm looking for. Extrusion frame. Insert. Let's see. Actually, do I want to insert this just yet? I actually don't think I do. Let us go ahead and grab ourselves our extrusion first. 2020 extrusion. Insert. Okay. Modify. Align. Maybe not. Yeah. What if I instead, let's turn the plastic frame off, we don't need that. Tangent plane off this guy. 45 degrees. My reference angle is origin. There's the origin. Which one? I guess the y-plane. This would be minus 45. So do this. No. I actually didn't need to do that. Nope. Toss this on. No. Alright. Last time we did it from center, we're going to do it from center. Okay. We're going to do this from center. I was thinking I was going to draw the wall first, but again, there's no real reason to, because we can extrude it exactly the same way we did the other one. So, turn that off. Turn off our 2020 extrusion for just a second. 3 millimeters. And then draw 20 millimeters. 20. Do that. Connect that. Do that. And do... Actually, there probably was a better way of doing this, but we're going to ignore that for the moment being. For the time being. 45. Connect this. That is our connection point. That is past the center point, so we can just bring this straight back at a right angle, I think. Yeah, it will mirror. When it mirrors, it will just overwrite itself. It's not that big of a deal. Right angle, please. Thank you. Whoops. Back over here. Nope. Back over to sketch. Okie dokies. So that is the start of it. And then I want a 3 millimeter wall just to make sure that we have some meat there. And then we will go ahead and align up the 2020 extrusion, and then we'll do the same exact thing that we just did on the corner brackets and extrude out the little attachment flanges. This one we are not going to be able to get to, well, technically speaking, so long as I sink the head in on here, we could screw it on. Yeah, you know what? Let's go ahead and do that. So the thickness on this bolt head is, let us see. I am getting about 4 millimeters. I will go 4.5 just to be super safe. So this is now going to be, for sake of simplicity. Nah, not for sake of simplicity. I'm going to do this instead. There's that, and then I'll go 4.5 here. 4.5. Change this to that. Change this tangent to be tangent to this guy. There we go. And that should work. That should do donkey. And it's funny because this kind of looks, this straight line going across here kind of looks curved because it's contrasted with that. I swear I'm not going crazy. Okay. Yep. Let's see. The only problem with this current situation is that my 608s, I believe I said, was 7 millimeters thick, and the 2020 extrusion is 20 millimeters thick, which is quite a bit of a difference. A full half-inch thick difference in thickness, 1/4 inch on each side. So The biggest problem with that is that that does eat into our space for the expanding mechanism or the drive shaft, either one. Alternatively, and it's one of those things, it's just going to, let's see, so we're giving ourselves 4.5 here. That's an 8mm shaft that I'm looking at right now. The collar was only 3mm, but the hinges were bigger. Hinges were 4mm, 2mm on each side, plus 3mm bolt. So that's 7. So the hinges are taking up 7 off of this guy. So long as we go out 7, we should clear the hinges. The printing it though, printing it will be a little bit sketchy. Yeah, so what I was thinking is, I was thinking about changing this to something bigger than 7, let's say 8, okay? Extruding only this much rather, at 7mm, okay? Just to encompass the, and then extruding out this, let's do the center, just to, for demonstration purposes. So doing that, and then extruding out this, the 20, symmetric overall 20, like that, and then connecting the 2020 like that. That gives me the 7mm on the inside for the hinges. In theory, the hinges, again, it's just these connection points on the hinges are the only things I'm trying to dodge, not the hinges themselves, because the hinges themselves, the links rather, is what I should be calling them, the links, should be completely flattened out by the time it gets over to this side. Although they're not flattened out on this side, which is a little bit of a problem. Although the plastic can just go out the backhand side, so the backhand side can be designed differently. Or not differently. We could design it the same way on either one, and then just have all 20mm instead of going this way. Instead of doing symmetrical, we could instead do one side, and then from object, that guy minus 20mm. Try that again. There we go. We could do that, and again, the hinges on this side, these links right here, should be completely flat by the time they get inside of this part right here. And this part, otherwise, if we keep this orientation going to this guy, will obviously be out the backhand side. So that's how we could do this. Otherwise, I know I spent about half an hour on this so far, but the 2020 extrusion does not seem to be a good way of doing this at the moment. And we do have the plastic frame as an option. So, the other problem with using the 2020 extrusion is that we have to use extra 2020 extrusion in the bottom here to hold them together. I guess that's technically not true. Technically, I could modify these corner brackets and put a hole through them for the threaded rod like we're doing for the plastic mount. But I have been complicating things for a while now, and I think we should probably stop ourselves at some point. So it is technically possible to do these other mounts, but the amount of time I'm spending on this is actually a little silly. Not a good excuse, honestly. Genuinely not a good excuse, because I do a lot of silly things on this that aren't strictly necessary. So one of those things, kind of an invalid criticism of the current situation. However, I do not feel the need to use 2020 to make this mount, especially because this is frankly not that bad. And if I was concerned about the plastic, again, we could try hollowing this out to save a little bit of plastic, but may not be necessary. So I think we keep it like that for right now. Just keep the plastic mount and call it good there. The next issue that we need to solve is the translation of the motor. Now the motor on the front end, so let's bring all this stuff together right now. I will go ahead and move the coiling mechanism back away from the encoder. So it should be in line. Do I want to do that physically or with the alignment tools? I guess I will use the alignment tools because I gotta use the alignment tools anyway. Align the origin over here. That origin with... Okay, that's the origin there, so I gotta go down to encoder wheel mid plane. Was it on hub? Yeah, there we go. And that did not move the whole entire object. Excellent. Excellent. And I do not have joints built on all this. Let's try this one really quick. Turn that off. That one, okay, that one also moves. Although I brought a link with me. Just one link. I moved just one link, but... Okay, that's because that has the revolve on it. That's why. So if I add all the links in, we should get there. Let's see. I am, for the sake of getting this done right now, just going to physically position this. Let's see. Back a little bit more and then up. Now, one of these deals, I did mention that we could build links to link these together, and that would provide stability to this. Given the size difference of what I've ended up with doing here, that is less feasible than it used to be. So, what I'm going to suggest instead is putting this on a piece of plywood or something similar, and then building little L brackets and L bracketing this stuff down. You know, both this and that to the plywood. That is the solution I'm thinking is probably easiest to solve the problems with. So, that is that. Now, as I was saying, because I interrupted myself, when we put the motor out here, that can basically be whatever. It could be a motor driving just the filament, or not filament, but you know, the cable, the cord, whatever it is, by itself. Just pulling it through a little motor and idler wheel setup, or double motor setup, or, you know, motor plus geared opposing wheel. You know, a bunch of different options there. Or instead of geared, you know, pulley. A pulley moving the other top wheel in the opposite direction. When we set it up over here, though, we do need to obviously put a sprocket or a pulley. And I just moved that because Fusion, for some reason, lets you move stuff. Don't know why, but it does. So we could put a sprocket or a pulley on this thing. Again, I was talking about just pinning through the shaft, or alternatively grinding it down into a D shaft. Those are still options on the table. Either one works. But we got to get something on there on the output. And then we got to create a system for hooking our motor up to it. Let's see. So it's one of these things where, because there's so many variables here, I'm not sure. It's kind of like the frame, right? The frame, I was going to do like 3 different kinds. There's a bunch of different things we can do here. Again, duplicating the CAD on this sprocket that is on this motor that I showed you guys is a bit difficult. And I need to mate it to this guy. This is all stuff that I'm going to have to figure out, I think, off stream. I don't think I can actually do this stuff on stream. And furthermore, it is such a small feature that I'm thinking to myself that I'd almost need an SLA printer to do it accurately enough. I'm not even sure I can do it with a FDM printer. And furthermore, as noted before, the mechanism to drive this could just be a wheel, a crank, anything. You could literally put your hand on the spool and pull it as well, turn the spool by hand. So, I really don't want to spend another hour or 2 designing options here. I kind of want to move on to the code. Because again, I literally could just move this by hand, in theory. And then, again, this encoder will output the amount that we have either pulled out the end. Again, just pull cord through this thing to despool it, or, you know, it will record how much we spool onto it by rotating the shaft by hand. So there's not a lot of reasons to actually go through all this effort right now on stream. The more important thing, especially because, you know, I would make a mount specific to this one motor, which again, I believe got out of an airsoft gun, which therefore means that you have no option to get one. Your options to get one yourself is very limited, and therefore this does not help you. So I think I'm rationalizing this correctly, and I should just leave it at this. One of those things where, you know what? I am going to go ahead. I know I'm waffling here, but let us go ahead and just throw a quick handle on here just for completeness sake. All right. So I was aligning everything else. Yeah, I guess I'll continue to do that. There's center, project out this guy, face. Let me turn this stuff off so that it is not getting in my way. Don't accidentally get something I don't want. 3 millimeters is the wall thickness we'll be going on. Although, maybe I go a bit thicker. Maybe I go like 5 because, let's see, what looks good on a handle? Well, actually, nah, you know what? It's one of those things. I was going to say, maybe I just use the rod itself as the handle, but I did go and print out, obviously, the handle for the arcade stick. So, let's go with 1.5 inches today. I think I did something like 3 inches on the handle on the other one. I think I'm going to shoot for 1.5 inches today. And actually, it should be 2 pieces anyway. So I'll go 5 here. This distance from here to the center line of that should be like 3 inches, let's say. And like 2 inches. I just want to give myself enough space that I don't hit my I don't hit my knuckles on the ground while I'm turning this. So we will go ahead and do that. We'll go ahead and make ourselves the same offset up here. And I will use another 5/16 8mm rod on the inside here. And let's go ahead and just tangent this guy up. We'll extrude that out. 5 is the number I'm using right now, so 5 this number is going to be. 5. And Control Z. 5. And new component. There we go. Let's see. So that's 5. I have 15 to work with, so let's do 8 inches on the hub. Or 8 millimeters, rather. 8 millimeters. And I guess I should just go ahead and make a construction line for this. Technically speaking, I can get away with using the center line, but it is less precise. So we'll go ahead and do that. This is the... what do I want to call this? Handle lever arm, I guess. I don't know. I call everything in lever arm. Handle extension. Back of handle extension. Create that hub I was just talking about. We will go ahead and tangent it. We'll make it the full 5 millimeters down here, and then bring this out 8 millimeters, as I was saying. I will not go ahead and do a hub on this side. Back to now that I've got my tap and die set, and it's one of those things, even if I didn't have that, I could use a collar up here. So I'm just going to use one of those two solutions, either put a nut on this side and a nut on the other side, or put a collar on each side. Either way works. But for the time being, come in here and get myself the front of handle extension. Front of handle extension. Grab, nope, come back up to handle first and then grab that. Project that out. Let's see. I think I decided, was it 5 or 6 inches last time? I think I'm going to go with 5 inches this time, one way or another. So let's go 5 inches. And this will be the handle rod. So this is another 8 millimeter rod. And actually, let's do that two-sided. The back side, I will give myself a 1/4 inch. Oh, actually, 2 object. I should do it a 1/4 inch out the back. So 25 inch. There we go. And this actually is going to go up to 5 and 25, so that I have an area on the end as well. So there is that. That is the handle rod. And then we can, whoops, don't start a sketch on the handle rod though. Front of, there we go. Project that out. And then I will do a similar thing that I did before, where I made it lofted out. I lofted it out. So let's see. Actually, let's Control Z and make the component first, because I'm going to need some planes to do the lofting on anyway. So new component. Handle grip. And now let's hop back in here. Project that out. Key. Turn that stuff off. Let's see. So I was saying 1.5 was going to be what I was going to try out for this one, for the handle grip size at the max. So let's start out at 1 inch, go to 1.5 and see how that looks. So 1 inch there. And then off of Handle extension, front of. We go 2.5 is the center of that because we went 5 inches. And then the other side would be 5 inches. Okay. Now I can close this back up. First loft, or I guess back loft. This is mid plane, or maybe handle grip mid plane. End of handle grip. Hop in here, project this out. I just need this circle really. And then 1.5. Finish. Grab that guy. Project out the original circle so that it's always the same size. Finish. And then loft. Get our loft on. That is not loft, that's rib. There. And let's just play with this a little bit. Nah, I think I like it better. Yeah, I think I like it better being a bit more round. Yeah, I don't really want to mess with anything else. Okie dokies. Looks good to me. Although, as usual with loft, it does not like the holes in the middle, so we'll go ahead and fix that. Distance all. And, whoops. Middle loft. And loft. And there we go. That is the whole handle. Turn these guys back on. And now we just need to move that to the end and we should be good. So, actually this side. I'm going to do this side here. And this does bring up the point that... Oh, hold on. Before I do that, let's go ahead and make sure that this is all rigid. Actually, it shouldn't be rigid, right? It doesn't matter if it's rigid or not, actually. So, for the sake of simplicity, I'm going to make it rigid first. I do, however, need to add another... let's see... just another lock nut, which I'm thinking, I forget, was it 7 3/4. So another 8, let's say, to the end of this rod. So back up, come down to this, add another 8, so that's 32 now. Everything else is going to stay where it's at. That just gives me space on the end. So modify align. You here, and then I will slide you back 8 millimeters, -8, please, thank you all. And I should have a little bit of a gap between there. I do. That's good. Technically speaking, it's probably not a problem if that is pressed right up against there, but just for the sake of it, I want to leave a little bit of space. That right there, finished position. That right there will be a lock nut. Again, I'll use either backup nuts or a lock nut or something like that for back over here, or collars, you know, on the back side here, etc. Threaded rods with nuts on the bottom here. And then this right here, again, because I'm threading stuff now, I might just thread the ends here and then put nuts on it. Otherwise, I can always use either a pin or a, what do you call it? A collar. Either way works. I could just, you know, drill a hole, put a pin through, and be done with it. Cotter pin. Whatever. Homemade cotter pin. So that is that. And let's toss some more colors in here because I don't have it. Plastic. Scroll up. Let's hop all the way up top so I can see what colors. Alright. Cool. Cool. Again, I do believe I need to go back and steal some more colors out of the other thing. I keep on saying I need to do that and I don't. So for the meantime, I guess I'm just going to reuse red on the inside here. Let's grab, I don't really want to do yellow because the orange is right there. So blue on the hinges. Cool. Always nice when it does all of them at once. And then up here on the end, I guess you're green now. Cool. Cool. Alright, so that is the very basic setup for a manual version plus an electronic encoder. And we will obviously go ahead and put a display screen on it. Actually, I guess that's another stream in and of itself. This creating the electronics box to hold a probably do a 2x16 LCD, and then the Arduino. That is, oh, and then some buttons. A tear button. Yeah, I think a tear button, and probably, well, until we hook up the motor. If we hook up the motor, then we also need at least up and down buttons / plus minus buttons. You know, the up and down buttons can act as plus minus buttons to set the amount that we want the motor to either coil or decoil. And then, just for the heck of it, we could also include a little piezo, whatever they could call it, piezo buzzer, just for the heck of it. Oh, and then a push button for go, a push button for accept, unless we want to double up on the tear button. The tear button would only be a tear button on the main screen. It wouldn't be a tear button. It could be the accept button on, or we still need a cancel button though. So it could be tear cancel as one button and then accept as another button. Yeah, those are the options. So back to, technically speaking, I guess we also, after we have the electronics in place, want to go ahead and design an electronic box as well. But we will wait till we actually get to that point to do another design stream for this. So, as always happens, this has been a significantly longer process than I anticipated because I decided to complicate things. Thank you for hanging in there with me if you have been. Otherwise, projects proceeding as normally. Refer to the most recent project update video for any more information about how the other projects are going. Otherwise, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.